So moving ahead, we will solve or we will derive sum of trigonometric identities, which is very much useful throughout your mathematics. Plus, in some technical papers, we require these identities. So rather than memorizing or keeping in mind, we will learn how to derive those identities. So this is hypotenuse, so we know this is opposite and this is adjacent. So from Pythagoras theorem, we know that hypotenuse square equals opposite square plus adjacent square, right? So to derive the first identity, we divide whole by hypotenuse square. So what happens? Hypotenuse square divided by hypotenuse square equals opposite by hypotenuse. I will write this as whole square plus adjacent divided by hypotenuse whole square. So what happens here? This gets cancelled. 1 equals, what is opposite by hypotenuse? Yes, you are right, sine square theta plus what is adjacent by hypotenuse? Yes, cos square theta. This is very much important identity where sine square theta plus cos square theta equals 1. So what is this? Sine square theta plus cos square theta equals 1. From this we can derive further. So sine square theta equals 1 minus cos square theta, that is we are just moving cos square theta other side. If you require value of cos square theta, then just move sine square theta at a different side. So we derived or we discussed from one identity other two identities. So first thing is we need to remember Pythagoras theorem. Then to derive this first identity, we divide whole thing by hypotenuse square. Then opposite by hypotenuse is sine, adjacent by hypotenuse cos. So cos sine square plus cos square equals 1. From this we took sine square separately and cos square separately. So let us once again write sine square theta plus cos square theta equals 1. So to derive next identity, we will divide with sine square theta first. So what happens here? Sine square theta, that is I will write whole square divided by sine theta whole square plus cos theta divided by sine theta whole square equals 1. So what happens here? This gets cancelled. So 1 by sine square theta, this is 1 plus cos by sine. We know sine by cos is tan, cos by sine is cot square theta equals 1 by sine is cosecant, that is cosecant square theta. This is the second identity. Clear? So we took the first identity and we divided the whole by sine square theta. Clear? Now once again we'll take the same identity and we'll derive other equation or other identity equals 1. This time we'll derive or we will divide with respect to cos square theta. So what happens? Sine square theta by cos square theta plus cos square theta by cos square theta equals 1 by cos square theta. So what happens? Sin by cos is tan. We have square. Tan square theta plus whole things get cancelled. That is 1 equals 1 by cos is secant. 1 by cos square is secant square theta. This is the third identity. Clear? So using Pythagoras theorem, we derived sin square theta plus cos square theta equals 1. From that, we derived 1 plus cot square theta equals secant square theta. Then tan square theta plus 1 equals secant square theta. Again, if you want further, you can derive the values from here. If at all you required tan square theta, so secant square theta minus 1. If you required cot square theta value here, cot square theta equals cosecant square theta minus 1. Clear with this?